In this video, I will work through the answers to a few of the questions from the packet I gave you with problems from Chapter 6 and Chapter 8. That packet, it was actually a two-page sheet of paper, front and back, started with Chapter 6.4 here and had you solve the equation given this set of absolute value equations. So I'm just going to do two. There are 6 here, and I'll work through 2, and I'll hope that that will be enough to help you understand how to do the other 4. The first one here, absolute value of x equals 8. These absolute value bars, basically what they do is they strip off any negative sign that might be inside. So the answer over here on the right will always be positive. The absolute value of anything is positive. Think of it this way if you want to. Think that you're walking along a number line. Imagine this spot right here that I'm indicating here is 0. You could walk 8 spaces to the right and you would reach positive 8. But you could also walk the exact same number 8 spaces to the left and reach negative 8. The number you'd be at over here would be negative 8. But how many spaces did you walk? 8. Okay, so the same thing here. If you strip away those absolute value bars, now x could be 8, but x could also be negative 8. Let's look at another one over here. Number 6 this time. The absolute value of x minus 4 equals 3. Well, before I figure out what x is, like the last slide, I'm going to have to get it out of the absolute value bars, but even before that, I've got to get x by itself. So I've got to move this 4 over. And so I'm trying to grab this. It's not pulling. Interesting. Got to add 4 to both sides. So the 4 goes away on the left, and on the left I'm just left with that absolute value of x equals. And on the right, 3 plus 4 makes 7. Okay, so now x, the absolute value of x, I should say, could be 7. That means without the absolute value bars, x could be 7 or it could be negative 7. I could have walked 7 spaces to the right from the start, or I could have walked 7 spaces to the left from the start. And that's why you got 2 different answers. From there we moved on to slightly more complicated questions. Now we've got some stuff going on inside the absolute value besides x by itself. First one I'm going to look at is the first one that's given to you here. So I've got the absolute value of x minus 2 equals 3. Well, it's just like the very first one that I showed you back here. Could be 8 or could be negative 8. So in this case, could be 3, could be negative 3. So let's look at it that way. X minus 2 without the absolute value bars could be 3 or it could be negative 3. Now let's get these both. In both cases, let's get x by itself. So in both cases, I'm going to have to add 2. If I add 2 to the first one, I've got x turns out to be equal to 5. If I add 2 to the second one, x turns out to be negative 1. Notice these are 2 totally different answers. This is not one of those plus-minus problems. In one case, I've got 5, and I know that number is a little hard to read because of this pen. But it's not a 6, it's a 5. And in the other case, it's negative 1. Let's look at a slightly more complicated problem. Let's look at number 15 here. Now I've got 2 different things going on inside the absolute value. I'm adding 8, but I'm also multiplying by 3. Well, without the absolute value bars, 3x plus 8 could be 7, but it could also be negative 7. If it's 7, then I'm going to have to first add 8. Let's just do both at the same time, actually. I'm going to have to subtract off 8, I mean to say. I have to subtract 8 away from both sides. So this cancels out, and in both cases, on the left, I'm going to have 3x. On the right, well, this one is going to be negative 1. This one's going to be negative 15. So now if 3x equals negative 1, over here, x equals negative 1/3. And over here, moving the 3 over, dividing negative 15 by 3, I've got x equals negative 5. So once again, 2 totally different answers, negative 5 and negative 1/3. Notice they're actually both negative in this case. There's no reason that one has to be positive and one has to be negative. That's not necessarily the case. And the 1/3 and the 5 have basically nothing in common. These are two different problems that you solved, one on the left and one on the right. Let's move on. From 6.5, you had to be able to sketch the graph. Well, let's look at, first of all, number 20 here. Okay, that was a bit of a mistake. I didn't want to reveal the graph quite right away. Looking at number 20 here, I've got x plus y is less than 3. Remember, there are some key basic steps to graphing an inequality. The first is to draw the line of the equation. So you're going to draw a line for x plus y equals 3. The next step is going to be to decide whether or not that line should be dotted or solid. And then the third step is going to be to decide which side to shade. Well, let's start with the first step, figuring out how to draw the line for x plus y equals 3. Well, my recommendation is to do the cover-up method. Imagine that I'm covering up this y here. So what I've got is x equals 3. And I make a dot where x equals 3. And that's what I revealed a little too quickly here. There's that dot where x equals 3. Now, if I cover up the x, I've got y equals 3, and I make a dot there as well. So now I've got dots in both cases at the 3. Once I've got 2 points, I simply draw a line through those 2 points. These happen to be 2 intercepts, the y-intercept and the x-intercept, all the easier to figure out what the equation is, but any 2 points are all you need in order to draw a line. So let's go ahead and draw that line. All right, so that tool there should work for doing the graphing. So I'm going to have a line. I'm going to draw it in both directions here, just to be precise. And that's about as well as I can do with this tool. Okay, so now that's the line for x plus y equals 3. Next step, should it be shaded or not? Well, it turns out that's not underlined. So I'm sorry, should it be dotted or not? It's not underlined, so it should be dotted. There's no easy way on here for me to make this look dotted. But I've told you guys before, if you forget, if you're working with pen, for example, and you forget to do it, it's fine by me if you simply write in the words dotted. So I'm going to go ahead and do that here. Now the question is, which side should be dotted? So maybe I'll put the dotted word right there. I'm sorry, which side should be shaded? That's the last step. It's a dotted line, that's the line. Now which side to shade? What I've told you to do before is to look at which side you think is probably going to be shaded. It's probably going to be the side that the arrow is pointing to. So it's saying less than this time, so probably this side over here is shaded, not this side over here. So let's try a point that's over here in the area that I think is going to be shaded and plug it in. 0, 0 is a very easy one to work with. So I'm going to end up saying 0 plus 0 and ask myself, well, let's write it out. 0 plus 0. Is that less than 3? Yes, it is. It is less than 3. So 0, 0 is on the side that ought to be shaded. So that's the side that ought to be shaded. And a drawing as simple as that would be perfectly satisfactory in answer to this question. Sketch the graph of number 20. Done. Let's move on to another example. Okay, in this case we're looking at 25 here. Again, graph the line first for the equation, then figure out whether it should be dotted or solid, then decide which side to shade. Okay, so to draw the line, I could do the cover-up method. It's a little tricky just because I'm going to end up with a fraction. If I cover up this y here, I've got 3x equals 2. So then to move that 3 over, I divide it away, so x becomes equal to 2/3. So I can make that spot. Let's see here, let's just get rid of it here. And I've made it here, my best estimate of where 2/3 appears on the x line. Similarly, I cover up the 3x. Now I've got negative y equals 2. Well, if negative y is 2, then y is negative 2. And there's my green spot at y is negative 2. This is pretty good. If you're not happy with this because it's a little hard to find exactly where 2/3 is, you can always rewrite this inequality to make it a y equals kind of equation. So that's what I've done here. I'll just move this out of the way for a second. 3x minus y is greater than or equal to 2. If I move everything but y over, I start by moving 3x over. So now I've got negative y is greater than or equal to negative 3x plus 2. See, I've just moved the 3x to the other side. Well, I don't want negative y, I want y. So I divide everything by negative 1. That means everything's sign changes. The y, negative y becomes positive y. The negative 3x becomes positive 3x. And the positive 2 becomes negative 2. The other thing to remember when you're doing inequalities, divide by a negative or multiply by a negative means you've got to change the direction of the arrow. So I end up with y is less than or equal to 3x minus 2. The line I would draw, though, would be y equals 3x minus 2. My y-intercept is going to be at negative 2, and it already is there. Look at that. And my slope's going to be up 3, rise 3 over 1. So let's just look at what that would be. That would be from this spot, rise 3 spaces, that's 3 spaces, over 1 space to right there, and now I draw my line through, and I think what you're going to find is that I end up, in either case, whether I did it the first way where I just quickly drew those 2 green dots, or this way, I end up with the same line. Alright, so there's my line. Solid or dotted, look at this equation, or not equation, inequality. The arrow is underlined, therefore it's solid. Which side should I shade? Well, this time, I'm guessing, since it's a greater than, that this is the area that should be shaded, not over here. Let's try a point from over here. Let's just pick something. What if I picked that point right there? That point is 5, 0. So 5 for x, so I've got 3, oops, let's switch pens to something you'll be able to read. 3 times 5 minus y, well, minus 0, I'm sorry, minus 0, not y. 3 times 5 minus 0, well, that's 15, or 15 minus 0, but 15. Is 15 greater than 2? Sure it is. So this side is the side to shade. And I don't really want all this stuff over here. I'll erase that just to indicate what the graph's supposed to look like. I'll delete all that off. And that is a perfectly satisfactory graph. Now maybe you would shade a little more than I have here. This pen is a little hard to control. But that's the graph of 3x minus y is greater than or equal to 2. My video, I can already tell, is going to go beyond the amount of time I have available here, so I'm going to make a second video. I'll pause here, and we'll pick up the story on the next video.